Okay, so I said I would put up a little lecture here on the periodic table, and this is just basics about the periodic table, kind of one big overview. If we would have been in class together, I would have spent a lot of time going through all of this stuff on the periodic table. You'll eventually get to the point after we get through this chapter where you'll be doing a scavenger hunt. Some of the stuff would be fairly easy, as long as you have a periodic table sitting in front of you. Some of it may be a little bit more difficult, or a little bit harder to answer the questions. Hopefully this might help a little. I'd also like to just kind of go through some basics of the properties. This would have been something we spent a lot of time in class on, talking about the periodic table, going through it, talking about it some more, explaining this, talking about it some more, going over some basics, going over some more in-depth stuff. So hopefully, if you take time to listen to this, this will help make a little bit easier for you to understand the periodic table, because there's a lot going on here. And again, you don't ever have to memorize it. And if you get into college chemistry, that's a possibility. They might have you memorize parts of the periodic table. But it's good to know some basic things about it, and it's good to understand some basic things about it, especially as you're getting into your homework on it. There will be a small project, not on the periodic table, but just a specific element that you'll be getting as well. So let's start here. I'm going to start on the left side. So here we go on the left side. I've mentioned before in several different lectures that when we have up and down columns, they're what we call groups or families. Families, as you know, have a lot of similar characteristics in them. Obviously, there's differences, but there's also similar characteristics. You might all have the same color eyes, or the same type of hair, or something along all this, but then there's obviously differences as well. So that's what families are like in the periodic table. So this is what we call the alkali metals. Alkali metals are ones that are found on the very left side in group 1. And I've mentioned several times throughout lectures that I've given that 8 is a magic number when we're talking about electrons. Electrons are the things that atoms use to bond with each other and to form compounds. And if you have 8 electrons in your outer shell, then you're happy. You don't need to bond with anything else. But if you have any less than that, you're going to want to bond with something and create a compound of some sort. If you only have 1, that means that you need 7 more to be happy. So you probably are very willing to give up that 1 to something that's looking for 7. You're very willing to give up that 1 to something that has 7 and is looking for 1. And so you're very reactive. So things like lithium, sodium, potassium, rubidium, cesium, francium, all extremely reactive elements. And these reactive elements form compounds most commonly with those that are found over on group 17, because they have 7 electrons that they want to bond with. And so 7 and 1 makes 8. And so a lot of times you'll see these types of things making compounds with this. The most common, if you've ever heard of table salt before, the scientific name for that is sodium chloride. So it's taking sodium and chlorine, putting them together, and you get table salt. So that's a real common compound that's formed from those in the alkali metal group, with those that are in group 17 are the halogens. And so that's that family. Now notice hydrogen sits up above here. It's not actually part of this family. It kind of is, but it's not really. It's kind of an extra to that family. And the only reason why it's put over here is because it only has 1 electron, which means it needs to do a lot of bonding. Usually all the hydrogen that you'll find even here on Earth is not in its gas form, which hydrogen is a gas. It's found mostly in water, because it's very common. A very common way for hydrogen to make a compound is to put it with oxygen, and you make water. So that's why you don't see hydrogen hanging out by itself, mostly because it's very reactive as well. All right, going into the second group, group 2, which is this column 2. And again, 2 valence electrons means that, or 2 electrons that are involved in bonding, means it's also going to want to give up those electrons very easily. So it wants to bond with something that's looking for electrons, and it's looking for 2 electrons. So a lot of things that you'll find that make compounds here, sorry about that. Things that make compounds are going to be things that you find in group 16 because they have 6 valence electrons or 6 bonding electrons. So 6 plus 2 makes 8. And so a lot of times you'll see that these types of things will make compounds with each other. And they always want that magic number of 8, like I mentioned. Then we get into, and more things. This is group 2. It's called the alkaline earth metals. Again, very reactive, like I mentioned, like to make compounds with different things, so they don't necessarily found alone. Then we have the transition metals. So metals that are found in this basic group right here, all the way from group 3 all the way over to group 12. These are the things that you are going to find your most common types of metals in. So things like gold and silver and nickel and copper and zinc. Those are all things that are used to make different things very easily. And the reason why is because these types of things aren't very reactive. The transition metals aren't super reactive. They form compounds, but for the most part, they're not very reactive, which means that they're good for things that stay pretty stable. So there's a pretty stable elements. So these kind of that fall below down here, there's 2 like rows of those, and they're actually found in rows 6 and 7. Rows across are what we call periods. Just like each month starts a new, like every week starts a new week, and that's the new like week there. So from Saturday over to Sunday is a week. Then we start over again at Saturday and go across the calendar up to Sunday, and then we start over a new week. That's kind of what a period is. A period is like basically starting a whole new cycle. So all Sundays like are underneath each other in the calendar, and all Saturdays are underneath each other in the calendar. All Mondays are underneath each other in the calendar. And so as we start over, these are going to be things that have similar properties. So we get over to neon, and then we start over again at potassium. And again, we have all of the characteristics that are going across here. They hit to a point where, okay, this is the final types of characteristics. We need to start over here, where we kind of start our properties over again. So things that basically fall again in these families have similar properties, like I was saying. So again, very reactive here, and then we're talking about the transition metals. Now, period 6 and 7, like I was saying, so the ones that are going across, down below, these 2 periods basically have some stuff cut out of them and put down below. These are called the lanthanides and the actinides series, and the reason why they're put down below is for no other reason than the fact that they makes the periodic table not as wide. We're able to put it on a couple pages. If it was like any longer, it'd be harder to read, I think, and so they put them down below. Okay, so moving on to the groups over here, your nonmetals and metalloids. These are found over on the right side of the periodic table. Again, they all have their own families as well, and they have similar characteristics for those families. And then starting with like group 13 on, so 13, 14, 15, 16, 17, 18, we don't use like just the number, we use the number in the ones place to tell us how many valence electrons or bonding electrons that they have. So group 13, they have 3, group 14, 4, group 15, 5, group 16, 6, group 17, 7. And that's how many bonding electrons they have. And of course, we've talked about group 18, we'll kind of start there, they're called the noble gases. They have 8 valence electrons, which means they're happy. They don't need to make compounds. So things like these gases right here, they don't mix with other things. They're found kind of on their own, not in compounds, or they don't readily form compounds at all. So things like helium, which we put into balloons, it's okay, it's stable. They used to put hydrogen in balloons sometimes. If you've heard of the Hindenburg, Hindenburg had hydrogen in its balloon as it was used. They used to use those to kind of fly different places. And then the Hindenburg caught on fire because it was using hydrogen gas. Hydrogen gas is flammable. Helium is lighter than air, but lighter than oxygen, lighter than the atmospheric air, but it doesn't light on fire. So it's a really good thing to put in balloons. It's lighter than air, so it causes it to float, but it also doesn't burn in any way. The rest of these, again, are going to be used for different reasons. A lot of times you'll hear the term neon sign. When you basically kind of heat these gases up, they actually heat up and look different. They have different colors to them. So all of these have different colors to them. So they're not necessarily always a neon sign. Sometimes they'll be an argon sign or a krypton sign or a xenon sign. And just depending on which one you use is the color of gas that you'll get in the gold. Let's work backwards here. So here we've got group 17 and they're called the halogens, which is also very reactive. And I mentioned before, group 17 likes to react with group 1. We form a lot of compounds that way. Because this has 7, it's only looking for 1. This is willing to give up 1 to the 7, so they often will form different compounds there. They're also, like I said, very reactive. There's quite a variety here. We've got a couple gases, 1 liquid, and a couple solids. The yellow ones being metalloids, but these are all basically nonmetals in this group. So that's called the halogen group. Oxygen group is group 16. They call it the oxygen family because oxygen is at the top. It's also the most common and the most important of all of the elements in this particular family, in that we breathe a lot of oxygen. Oxygen takes place, is a big part of our respiratory system, allows for us to get energy out of the food that we eat, so we need oxygen for that. So we've got a gas, a couple of solids, and then some metalloids in this family. But again, they form compounds. The most common compound that is formed between anything here is hydrogen and oxygen. They're giving us H2O, which means this gives up 2 electrons because it's 2 different atoms of hydrogen, and then there's 1 atom of oxygen looking for 2 electrons for bonding, which is why it's H2O, not HO, or H1O basically. And so that's kind of the compound that makes there. Then we have the nitrogen family, again, named for the one at the top. Nitrogen is the hugest part of our atmosphere. We don't use nitrogen in its gas form, which is what we find in the atmosphere. We have to use it in more of a solid type form, which happens when plants basically take the nitrogen and fix it in their roots. So the nitrogen gets into the soil. The plants fix that nitrogen in a way that we can use it. So if we eat plants that contain that, we get our nitrogen that way. So it's a gas, and we have a solid here, a couple metalloids, and then at the bottom we have a metal from the metal part of the periodic table. So this has 5 valence electrons, so it wants to go with something that has 3 valence electrons. And then that makes, again, the happy number of 8. All right, going over to the carbon family. Carbon is like the only nonmetal in that group, but carbon happens to be one of the most important nonmetals for life. And that pretty much all of our food that we eat is made up of carbon. Carbon likes to bond with itself. It has 4 electrons, which means it bonds very happily with another carbon, and then they get 8 together. So a lot of carbon chains go into stuff. So carbohydrates are a carbon chain-based food, and proteins and lipids. All of those have carbon chains. Depending on how long the carbon chains is depending on what it is, if it's a lipid, a protein, or a carbohydrate. Again, this is the same stuff I kind of talked about before, but I wanted to kind of get it all in one lecture instead of kind of in between just talking about the periodic table in general and then talking about the metals, talking about the nonmetals. This kind of puts it all together. So hopefully this helps a little. If you're struggling with learning about the periodic table or understanding the periodic table, a lot of stuff going on there. Feel free to email me questions or send me a message on PowerSchool Learning if you really have some questions still on the periodic table. All right, enjoy.